So division, whenever you have f divided by g of x, what you're going to do, simply divide the functions. Okay, you have an f of x, you have a g of x, so I will be using this whole concept of division, f divided by g. What will I do for that? Let me write it over here. I can put a line also to differentiate from the other side. F of x divided by g of x. That's what I'm going to do. F of x divided by g of x. And how will that turn out? X square plus 1 whole divided by x raised to power 4 minus 1. X raised to power 4 minus 1. The brain break is done. We are now taking care of the next last part, which is a division, where the division will be closing this topic of operations or combining without composition. Now, the denominator here, x raised to power 4 minus 1, can be factored. How can that be factored? I will write down a rule, a formula here. Formula tells me whenever I have a difference of two squares, whenever I have a difference of two squares, I can write that down in two factors. First of the factors is an addition, and the second of the factors is a subtraction of the same numbers. That's the rule. Addition and subtraction of the same numbers. That's what I will be writing here. Then, where is it? Still appearing? Got it. So whenever you have difference of two numbers which are squared, a square minus b square, whatever is a and whatever is b, you will take the numbers, add those together, and then in the second factor, you will subtract those numbers. The question that we are looking at in that one, x raised to power 4 is a square of x square. This x raised to power 4 is a square of x square. And then 1 is a square of 1. So what I can write down in the denominator, this thing, x square square minus 1 square. Keep it in mind, don't be confused. This term is replaced with this one, because x raised to power 4 is clearly x square square. We are dividing now. We had the division of the functions. So I took the yellow one, which is f of x, divided by the g of x. And then with the division, I'm using this red written rule. Whenever you have two squares subtracted, you will use these factors to solve it. So I will be now bringing in these factors. Just one more minute, I hope, and we will be done. So I will keep the numerator exactly same. Denominator will now be written as x square plus 1 times x square minus 1. And then look for the similar things. Whatever is similar, we will cancel that out. What's similar here? X square plus 1 and x square plus 1. We can cancel it. I don't want to use the word cancel because actually it's being divided. 2 by 2 is a 1, 3 by 3 is a 1. Anything when you will divide it with the same thing, it turns out to be a 1. And 1 times anything will result the same function or expression. And that's going to be 1 over x square minus 1. X square minus 1. And if we will go for the domain for this function, the domain for this function has a restriction. I cannot have x square equals to a 1 because that will make it a 0. This is a restriction that we were talking about. So in this case, x should not be equal to, or x square should not be equal to 1. That's how the domain will be determined, because 1 over x squared minus 1 is the division. In this case, x squared should not be equal to a 1, or I will claim that x such that x belongs to all real numbers, x belongs to all real numbers, but it cannot be equal to a +1 or a -1. I can write it in this way also. And that's going to be the domain. These absolute lines, the blue absolute lines, these ones are making it sure that x should not be a -1 and should not be a +1, because in both cases, it will impact my domain. It will impact the existence of a function.